Hello, welcome to Philos Academy. Today I'm going to take you through Poisson distribution. So without wasting much time, let's start. Now the Poisson formula is given by mu exponent x times e exponent negative mu divided by x factorial. Now this mu here represents the mean, okay, and it should be a non-negative number. That is, it should be greater than 0. So it can be 0.5, 1, 2 going. And the x should be a discrete variable which can be what? 0, 1, 2 going. Okay. And this e is a constant. It is on your calculator. If you check it out, you see it there. It's a constant which is approximately equal to 2.71828. 2.71828. We call it Euler's number or Napier's constant. It was named after some two mathematicians, one from Swiss and the other person from Scotland. The one from Swiss, his name is Leonard Euler, that's why we call it Euler's number. The other person from Scotland, his name is John Napier, that's why we call it Napier's constant. Now you can also write the formula like this. Lambda exponent x, e exponent negative lambda divided by x factorial. What I want you to know is that you can represent this mu with lambda. That's another way of stating the formula, okay? So, lambda exponent x, e exponent negative lambda, just like the top one, divided by x factorial. But I'll be using mu, okay? I won't use lambda, but you can choose to use the lambda as your mu. Now, in Poisson distribution, the expected value of x is already the mean in the question, which is mu, or lambda, okay? And then the variance of x should be equal to the expected value of x, which is equal to the mu also. So in Poisson distribution, the mean is equal to the variance, but the standard deviation is equal to the square root of the variance. Now what makes binomial question different from Poisson question is that in binomial, you'll be given number of trials, which is n, and what probability of success. But in Poisson question, they would rather give you the mean. Okay. But there are some binomial questions that you have to use the Poisson formula to solve it. So in this video, I'm going to show you that. So kindly pay attention. So let's take some questions on this. Question 1 says, a sales firm receives on average 3 calls per hour on its toll-free number. For any given hour, find the probability that it will receive the following. A. Exactly 4 calls. So to solve this, when you look at the question, they said on average. Average means mean. Okay. So it means our mean is 3. So to solve this question, we say our mean, which is mu, is equal to 3 calls per 1 hour. Per hour. That's the mean. Now for question A. Question A says we should find the probability that it will receive exactly 4 calls. So probability that x is exactly 4 should be equal to. Now the formula says mu exponent x, e exponent negative mu divided by x factorial, isn't it? So we use the formula. Our mean is 3, isn't it? So we substitute it there. So 3 exponent x, and our x is 4. Times e exponent negative mean, which is 3, so negative 3, divided by x factorial, and our x is 4, so 4 factorial. So you are going to enter this on your calculator. Now to get it, now take your calculator, click on the division key. So at the numerator, enter 3 exponent 4 times. Now to get the e, now click on shift. After clicking on shift, then you check for a particular key, they've written ln on it, natural log, okay, ln. So you click on that key, it will give you the e, then you enter the exponent, negative 3. So come to the denominator also, and enter 4. Now to get the factorial, click on shift, and then look at the key right under the mode. Click on that key, okay, you are going to get the factorial. So press equal to, then you get 0.16803. So that is the answer for question A. So let's look at question B. Question B says, at most 3 calls. At most 3 means that x is less than or equal to 3. So that will be probability that x is exactly 0, or x is exactly 1, or x is exactly 2, or x is exactly 3. Now, to find the probability that x is exactly 0, we are going to take the formula again. So we have 3 exponent 0 times e exponent negative 3 divided by 0 factorial. 0 factorial will give you 1. Plus 3 exponent 1, the mean exponent x, okay, times e exponent negative 3 divided by 1 factorial. Plus 3 exponent 2 times e exponent negative 3 divided by 2 factorial. Then we do this also. 3 exponent 3 times e exponent negative 3 divided by 3 factorial. So you follow the procedure you used in solving this to solve this too. So when you put this on your calculator, you're going to get 0.04979 plus, when you enter this also on your calculator, you get 0.14936 plus, when you enter this third one also on your calculator, you get 0.22404. And then when you enter the last one on your calculator, you get 0.22404 also. So add the 4 results together. You're going to get 0.64723. So the answer to question B is 0.64723. So let's look at question C. Question C says at least 3 calls. So when we say at least 3, it means that the minimum should be 3. So we are finding probability that x is greater than or equal to 3. And that will be probability that x is exactly 3 or x is exactly 4, because it should be greater than or equal to 3, plus then you find for x is exactly 5, exactly 6. You don't know where you're going to stop. So for that matter, you can't use this formula to solve it. So I'm going to show you another way of solving this type of question. Now, just like how you learned word and opposite, that good, the opposite of good is bad, the opposite of small is big, arrive, leave, and the likes, okay. Now, it's important to know that the opposite of less than or equal to is greater than. The opposite of greater than or equal to is less than. And the opposite of equal to is not equal to. So to use another formula for this, this is how you state the formula. Probability that x is greater than or equal to 3 should be equal to 1 minus the probability of the opposite of this. So what is the opposite of x greater than or equal to 3? It should be x less than 3. So let's break this down. So we're going to have 1 minus into bracket. Probability that x less than 3 will be probability that x is exactly 0 or x is exactly 1 or x is exactly 2. We'll stop at 2 because it says less than 3, meaning 3 is not included. Okay. So we're going to have 1 minus into bracket. Now, to find the probability that x is exactly 0, we are going to have 3 exponent 0 times e exponent negative 3 divided by 0 factorial plus 3 exponent 1 times e exponent negative 3 divided by 1 factorial plus 3 exponent 2 times e exponent negative 3 divided by 2 factorial. So that will give us 1 minus into bracket. When you put this on calculator like you did in question A, you're going to get what? 0.04979 plus, when you put this also, you get 0.14936 plus, when you put the third one, you get 0.22404. So this will give us 1 minus. Now when you add the 3 results in the bracket, you're going to get 0.42319. So 1 minus 0.42319 will give us 0.57681. So the answer to question C is 0.57681. So let's look at question D. Question D says we should find the probability that you receive 5 or more calls. When we say 5 or more, it's the same as saying that at least 5. Okay, 5 or more also means at least 5. Okay, so it means probability that X is greater than or equal to 5 or more of it. Okay, so that will be probability that X is exactly 5 or X is exactly 6 going. But remember, we can't use this formula to solve it. That is why you need to know this so that you can use the complement method. So the probability that X is greater than or equal to 5 should be equal to 1 minus probability that X is less than 5. So that will give us 1 minus probability that X is exactly 0. Those are the things less than 5. Or X is exactly 1. Or means plus, okay. Or X is exactly 2. Or X is exactly 3. Or X is exactly 4. So this will give us 1 minus. Now, when we find the probability that X is exactly 0. Now, in question C, remember we got probability that X is exactly 0 to be 0.04979. So plus, we got a probability that X is exactly 1 to be 0.14936. And we got probability that X is exactly 2 to be 0.22404. Then we got a probability that X is exactly 3 to be also 0.22404. Plus, from question A, we got a probability that X is exactly 4 to be 0.16803. So this will give us 1 minus, when you add everything in the bracket, you're going to get 0.81526. So 1 minus 0.81526 will give us 0.18474. So the correct answer for question D is 0.18474. So let's proceed to the next question. Question 2 says, the number of telephone calls received by an office on average is 4 per minute. Find the probability that. So to solve this, we receive 4 calls per minute. So in every 1 minute, there are 4 calls. Okay, that's a minute. Now the question says we should find the probability that no call will arrive in a given 1 minute period. Now take a look at this. The question says 4 calls per minute. It means that in every 1 minute, there are 4 calls. So the same question is asking us to find a probability that no call will arrive in a given 1 minute period. So to solve question A, the probability that no call, it means X is exactly 0, no call, okay. That should be mean exponent X, that's 4 exponent 0, times E exponent negative 4 divided by X factorial, which is 0 factorial. So that will give us, now to enter this on your calculator, first click on the division sign on your calculator and then enter 4 exponent 0 times, then you click on shift, next click on ln to get this E, then you enter the exponent negative 4, then you come to the denominator, enter 0 and then click on shift and the key under the mode key to get a factorial. Okay, so when you press equal to sign, you get 0.01832. So 0.01832 is the correct answer for question A. Now let's look at question B. Question B says at least 2 calls will arrive in a given 1 minute period, also 1 minute. Please, when you are solving Poisson question, be very careful with the time. Okay, 1 minute, also 1 minute. So we are going to use the mean as 4 also. So probability that at least 2 calls will arrive, that is X greater than or equal to 2, should be 2, 3, 4, 5 going, isn't it? But I want us to use the other method, which is 1 minus the opposite of this. So probability that x is less than 2. So which will give us 1 minus probability that x is exactly 0 or x is exactly 1. So those are the two things less than 2. So with that, we are going to have 1 minus into bracket. Let's find the probability that x is exactly 0. That will be 4 exponent 0 times e exponent negative 4 divided by 0 factorial plus 4 exponent 1 times e exponent negative 4 divided by 1 factorial. Please always make sure you bring times when you are entering it on calculator, okay? Then you close the bracket. So this gives us 1 minus into bracket. Now from question A, we got this to be 0.01832 plus. Now you've entered this on your calculator, right? You can edit it by erasing all the zeros and replacing them with 1. Okay. So when you replace them, you get 0.07326. So this will give us 1 minus. When you add the two results in the bracket, you're going to get 0.09158. So 1 minus 0.09158 should give you 0.90342. So this is the answer to question B. Now let's look at question C. Question C says at least 3 calls. So probability that x is greater than or equal to 3. Okay, at least 3 calls will arrive in a given 2 minutes period. But the question says the mean is 4 calls per minute. Per minute means every 1 minute. But this question wants us to find for 2 minutes. So for that matter, your mean is going to change. If 4 calls arrive in 1 minute, then in 2 minutes it should be 4 times 2, isn't it? That will give us 8. So that will be 8 calls. 4 calls arrive in 1 minute. So in 2 minutes, the mean should change. Okay. So it should be 4 times 2. That will give you 8 calls. Okay. So our new mean is 8. It's not going to be 4 anymore. So to solve it, you have to be very careful. So this will give us 1 minus the opposite of this, which is probability that x is less than 3. So this will give us 1 minus into brackets probability that x is exactly 0 plus probability that x is exactly 1 plus probability that x is exactly 2. So that will be 1 minus into bracket. Now this time around our mean is not more 4, it's now 8. Okay, so you have to be very careful. So that will be 8 exponent 0 times e exponent negative 8 divided by 0 factorial plus 8 exponent 1 times e exponent negative 8 divided by 1 factorial plus 8 exponent 2 times e exponent negative 8 divided by 2 factorial. So that will give us 1 minus into bracket. When you put this on your calculator, 8 exponent 0 times e exponent negative 8 divided by 0 factorial, you're going to get 0.00034. When you do the second one, you get 0.00268 plus, and the third one will give us 0.01073. So this will give us 1 minus. When you add the 3 results in the bracket, you get 0.01375. So 1 minus 0.01375 will give you 0.98625. So the correct answer for question C is 0.98625. Now in case the question asks you to find the variance is equal to the mean. Okay, so the variance is also 4. To find the standard deviation will be the square root of the variance, which is square root of 4, and that will give you 2. So let's proceed to the next question. Question 3 says, the probability that a car will break down after falling into a pothole on a road is 0.00015. If 20,000 cars travel along the road, find the expected number of breakdowns and the probability that at least one car will break down. So to solve this question, look at this question. You realize that the question has given you P to be 0.00015, and then it has given you N to be 20,000. That is 20,000 cars. So you can easily find Q and then use binomial formula to solve it, isn't it? But for this particular question, we are not going to use binomial to solve it. We are going to use Poisson. The reason is, whenever you have a question that has a very small probability and a large sample size, okay, look at the probability. It's very small, 0.00015. Too small. And then the sample size is large. Okay, whenever you have such question, we are going to use Poisson to solve it. But let's go in accordance with the question. The question says, find the expected number of breakdowns and the probability that at least one car will break down. So they are asking us two questions. So let's answer the first one. The first one says we should find the expected number of breakdown. So expected number of breakdown means the mean. Okay, so that is N times P, which should give us 20,000 times P, which is 0.00015. So 20,000 times 0.00015 will give us 3. So it means the mean is 3. Okay. Now the second question says we should find the probability that at least one car will break down. So at least one car will break down means that one or more. That is, X is greater than or equal to 1. So that means 1, 2, 3 going, isn't it? But we are going to use the other formula which says 1 minus its opposite. So what's the opposite of greater than or equal to 1? It is less than 1. Okay, which is 1 minus, into bracket, probability that X is exactly 0 only, because it's only 0 that is less than 1. So probability that X is exactly 0. And this will give us 1 minus. Now to find the probability that X is exactly 0, what is the mean? The mean is 3, isn't it? So we say 3 exponent X, which is 0, times E exponent negative mean, which is 3, divided by 0 factorial. And that will give us 1 minus 3 exponent 0 times E exponent negative 3 divided by 0 factorial will give us 0.04979. So 1 minus 0.04979 will give 0.95021. So that is the answer. In case the question asks you to find the variance is equal to the mean, which is equal to 3. Okay. And then the standard deviation is the square root of the variance. So square root of 3 will give you 1.732. Okay. So let's proceed to the next question. Question 4 says, if approximately 2% of the individuals in a room of 200 are left-handed, find the probability that exactly 5 are left-handed. So to solve this question has given us probability P to be 2%, that is 0.02. And then we've been given the sample size to be 200. So for this, you can easily find a Q and then use the binomial formula, isn't it? But here we won't use the binomial formula because the probability is small and the sample size is large. Okay, 200. So let's use Poisson to solve this. So to use the Poisson, first we find the mean. Mean is equal to N times P. So that is 200 times 0.02. So 200 times 0.02 will give us 4. So the mean is 4. So the probability that exactly 5 are left-handed should be X is equal to 5. Should be the mean, which is 4, exponent 5 times E exponent negative mean, which is 4, divided by 5 factorial. So when you enter this on your calculator properly, you get 0.15629. So the correct answer for question 4 is 0.15629. In case the question asks you to find the variance and the standard deviation, the variance is also 4. Okay. In Poisson distribution, the variance is equal to the mean. And then the standard deviation should be the square root of the variance. So square root of 4 will give you 2. Okay. So the standard deviation is 2 and the variance is 4. So let's proceed to the next question. Question 5 says, the number of power surges in an electric grid has a Poisson distribution with a mean of 1 power surge every 12 hours. Mean of 1 power every 12 hours. Okay. And the question A says, what is the probability that there will be no more than 1 power surge in a 24-hour period? Now, to solve this, according to the question, the mean is 1. Okay, 1 power in every 12 hours. 1 power per 12 hour. Okay. But the question A is asking us that we should find a probability that there will be no more than 1 power surge in a 24-hour period. Now, when we say no more than 1, no more than 1 also means at most 1. Okay, so it means the probability that x is less than or equal to 1. No more than 1. Okay, so that will be probability that x is exactly 0 or x is exactly 1. Now, to solve this, the mean won't be 1. The reason is the question wants 24-hour period, not 12 hours. Now, how many 12 hours are in 24 hours? There are 2 12 hours in 24 hours. You can find 2 12 hours in 24 hours. Okay, so for that matter, you say 1 times 2. That will give you 2. So the new mean is going to be what? 1 times 2. Because there are 2 12 hours in 24 hours. Okay. 1 power is for 12 hours. So for 24 hours, it will be 2. For 36 hours, it will be 3. Okay. Yeah. So the mean is 2. So we are going to have mean, which is 2, exponent x, which is 0, times e exponent negative 2 divided by 0 factorial, plus 2 exponent 1 times e exponent negative 2 divided by 1 factorial. So when you put the first one on calculator, you're going to get 0.13534, plus when you put the second one, you get 0.27067. So add them together, the final answer will be 0.40601. So the correct answer for question A is 0.40601. So let's look at question B. Question B says, what is the probability that there will be more than 3 power surge in a 24-hour period? So they say more than 3. More than 3 means x is greater than 3. Okay. More than 3 means x is greater than 3. So that means 4, 5, 6, 7, 8, 9, 10 going, isn't it? But we can't solve that, so we're going to use the other method. So that will be 1 minus. What is the opposite of greater than? It should be what? X less than or equal to 3. The opposite of greater than is less than or equal to. Okay. So that will be 1 minus. Now, what are the things less than 3 and equal to 3? So we're going to have x is exactly 0, or x is exactly 1, or x is exactly 2, or x is exactly 3, since 3 is inclusive. Okay. So we have 1 minus into brackets. The mean is 2, because this question is also asking for 24 hours. Okay. So we're going to have 2 exponent 0 times e exponent negative 2 divided by 0 factorial, plus 2 exponent 1 times e exponent negative 2 divided by 1 factorial, plus 2 exponent 2 times e exponent negative 2 divided by 2 factorial, plus 2 exponent 3 times e exponent negative 2 divided by 3 factorial. So when we simplify this, we have 1 into brackets. The first one will give us 0.13534, plus the second one will give us 0.27067, plus the third one will also give us 0.27067, and then this will also give us 0.18045. So that will be equal to 1 minus, when you add all the results in the bracket, you're going to get 0.85712. So 1 minus 0.85712 will give us 0.14288. So the correct answer for question B is 0.14288 or 0.1429. Okay, that's in 4 decimal places. So let's proceed to the next question. Question 6 says, if there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page contains exactly 3 errors. So to solve this question, first we need to find the mean. Okay, the mean is equal to summation x divided by n. Okay, now what do I mean by summation x? Summation x means addition of all the errors. So all the errors put together is 200 in numbers, isn't it? Divided by n is the sample size. So we have 500 pages, which is the n, so 500. So 200 divided by 500 will give you 0.4. So this is the mean. So after getting the mean, we can now find the probability that x is exactly 3, because the question says find the probability that a given page contains exactly 3 errors. So that will be the mean, which is 0.4, exponent x, which is 3, times e exponent negative mean, which is negative 0.4, divided by x factorial, which is 3 factorial. So when you put this on your calculator, you get 0.0072. So the correct answer for question 6 is 0.0072. So try this question and compare your answer with mine. So for question A, you're going to get 0.06564. Then question B, 0.60934. Then for question 2, you get 0.0611 as your final answer. For the question 2, the mean should be 4.5, and then the probability will be 0.0611. So kindly solve it and then compare with mine. So I'll end here for now. Please do well to subscribe to the channel so that when I post the next topic, you can have access to it easily. Thank you.